The rest of this lesson is just application problems. So example 3 says a firm has total weekly revenue in dollars for its product given by R of X, where X is the number of units sold. So we need to graph this function in the window. How many turns are displayed? So when they give you a window like this is talking about my X. So this is my X min and X max. And then these are my Y's. So my Y min and Y max. So let's graph this. And notice this is actually not really in standard form since these are exponents are ascending. Usually those need to be descending, but whatever. And then we'll go in here to window and change our window to this right here. Now it doesn't tell me anything about X scale. If you want to just leave it as 1, that's perfectly fine. I'm going to make that 25 because that's just a little bit more reasonable. And what would a good Y scale be here? Let's say 10,000. I still think that might be a little too little, but be better than what it was. And then I'm going to hit graph. Okay, and the question it asks on part A, after we graph this function, is how many turning points are displayed? And I see 1, 2, which should make sense because we have a cubic function here, which means I should have at most 2. Okay, now because X represents the total number of units, what restrictions should be placed on X in the context of this problem? What restrictions should be placed on Y? Well, if my X is the number of units I am selling, I can sell 0 units, I can sell positive units, but it doesn't really make sense to sell negative units. So I need my units, I need my X to really be positive. And then my Y, because we're talking about revenue, not profit, not cost, but because we are talking about revenue, revenue equals the money that you are bringing in. I cannot have a negative revenue. Negative revenue would be really your cost. So I cannot bring in negative. So here, both X and Y or R, I can't speak right now, or your R, which is representing by the Y. Okay, so either both X and Y or X and R need to be non-negative. Okay, so part C, using your results from part B, graph the function in a new window that makes sense for the problem. So we are going to change our X min to be 0 and our Y min to also be 0. So if we look at my graph here, I need to restrict this to just my quadrant 1 right here, where it is positive X and positive Y. So I'll go in here to my window and change that to 0. And I'm going to change that then to 20. Change that to 0. And I'm going to keep that at 10. So now this is what my graph looks like. And so you can see it doesn't really look like a cubic function anymore, even though it does. This looks more like a quadratic because it's got the 1 turning point. But when I'm restricting it, it's just because I'm restricting that window, right? It is still a cubic. So what does the function have as a revenue if 60 units are produced? What does the 60 represent? Tells me up here that X is the number of units sold. So this is representing my X. So we will do trace 60, enter. And we're talking about revenue, so talking about money. So trace 60, enter, and we have a revenue of $163,200.